The question is the value of double integral 0 to pi by 2, 0 to cos theta or sin theta dr d theta is. Four options ABCD given. This question is from engineering mathematics. From the topic calculus, subtopic is multiple integrals. There is double integrals. Here, typing error, this is pi by 2. The solution is, so here, one integration having constant limits, other integration not. So whenever a limit containing theta variable, they are not theta limits, opposite in nature. So 0 to cos theta indicates R limits and 0 to pi by 2 theta limits. So given integral can be written as double integral theta is equal to 0 to pi by 2. And always integrate last with respect to a variable having constant limits. Automatically here with respect to first R integration inside R is equal to 0 to cos theta R sin theta dr integrating with respect to R first and then with respect to theta. With respect to R means theta terms constant. So this is a constant. So sin theta constant multiplying, which will not affect my integration. R integration with respect to R is R square by 2. Between the limits R is equal to 0 to cos theta. And then integrating with respect to theta between the limits 0 to pi by 2. So take out 1 by 2. This is 0 to pi by 2. Substitute upper limit R is equal to cos theta becomes cos square theta and then R is equal to 0, 0, cos square theta minus 0, cos square theta. So this simplifies to sin theta into cos square theta. Using definite integral properties, fourth property or by substitution method. So put cos theta is equal to change of variable is equal to t. Differentiate both sides. Cos theta derivative minus sin theta d theta is equal to t derivative is dt. And finding the new variable limits. Theta lower limit is 0. Here cos 0, 1. So t lower limit is 1. Theta upper limit is pi by 2. Cos 90 is 0. So t upper limit is 0. So t limits 1 to 0. So to eliminate this minus, interchange of limits affected by minus. That minus into this minus become plus. I can write half times t limits 0 to 1 instead of 1 to 0. Interchange of limits affected by minus sign from the definite integrals. So this is t square dt. Since integral a to b is equal to minus integral b to a, change of limits. So t square integration with respect to t is t cube by 3 between the limits 0 to 1 of times. So this simplifies to 1 by 6. This is t is equal to. So the answer is 1 by 6. Accordingly, the option is C. This is end of the question. The question is, let the superscript t represent the transpose operation. Consider the function f of x is equal to half times x transpose, this is superscript t, into q into x minus r transpose into x, comma, where x and r n cross n vectors, n cross 1 vectors, and q is a symmetric n cross n matrix. The stationary point of f of x is. So this is first observation. Both are column vectors x and r. Q is n cross n square matrix, which is symmetric also given. Stationary point means. So first of all, four options given ABCD. This question is from engineering mathematics from the topic calculus, maxima minima related because stationary points. Of course, this is a linear algebra matrix related. That is 2 chapters, multiple chapters application. So solution is. So let us consider n is equal to 2. Similarly, we can get answer for n cross 1 vectors also. Let n is equal to 2. Okay. And that q 2 cross 2 automatically will become, which is symmetric matrix, means Q transpose is equal to Q. I'm taking A, C, C, B, which implies Q transpose is equal to Q. That is symmetric. And X is equal to 2 cross 1 vector, that is column vector, taking two variables x1, x2. R is also column vector 2 cross 1 vector. This is 2 cross 1 instead of n cross 1. R1, R2, two terms, two elements, 2 cross 1, cross 2. Okay. Now, implies your function f of x is equal to half times x transpose. That is column vector transpose is row vector 1, x2 multiplied with A, C, C, D, that is Q, multiplied with X, that is column vector X1, minus R transpose row vector R1, R2 into X, column vector X1, X2. So please simplify. This is half times X1, X2 into, I am multiplying first these two. First row into first column gives AX1 plus CX2. Second row into first column gives CX1 plus BX2 minus, this is R1 X1. First row into first column, first row into second column, that is R1 X1 plus R2 X2. So 1 cross 2 into 2 cross 1 gives 1 cross 1, which is single element. This is R1 X1 plus R2 X2. So this is 1 cross 2, 2 cross 1. Finally, this is an element 1 cross 1. Similarly, 1 cross 2, 2 cross 1, you will be getting 1 cross 1 element. So that means here AX1 square plus BX2 square plus 2C X1 X2 after multiplying minus R1 X1 minus R2 X2 is not R square, R2. Okay. Now this is a two variables function. Let f of x is equal to phi of x1 comma x2. Let us take the two variables x1 x2 equal to ax1 square by 2 plus bx2 square by 2 plus cx1 x2 minus r1 x1 minus r2 x2. Two variables function. Very, very important logical question. Good conceptual question. This example for mechanical students, it was obtained in that is GATE 2021. So because they are asking stationary points for stationary point of f of x, that is phi of x1 comma x2, we have the necessary condition is first order partial derivatives 0. That is dou phi by dou x1 is equal to 0. Nothing but phi term, phi of x1 comma x2. And dou phi by dou x2 is equal to 0. With respect to x1 partially means x2 constant. With respect to x2 partial derivative means x1 constant. So this is first term ax1 square by 2 derivative is ax1 plus x2 square derivative 0 plus cx2 minus that is r1 and that is 0 minus is equal to 0. And with respect to x2 first term 0 plus bx2 plus cx1 minus 0 minus r is equal to 0. So this can be expressed as ax1 plus cx2 is equal to r1 and other equation cx1 plus bx is equal to r. These equations, two non-homogeneous equations, can be written in matrix form as, here I am writing A, C, C, B multiplied with column vector x1, x2 equal to the column vector r1, r. This check. So this looks like q times x, q into x is equal to r. Okay. So because they are asking stationary point of fx, here f is a function of one variable, we are need to find x value. So here x is equal to question. Okay. So to find x, eliminate q. That means pre-multiplying by q inverse into q into x is equal to q inverse into r. A matrix into its inverse is identity matrix. Identity matrix into x is x. So this simplifies x is equal to q inverse. So the answer is the stationary point of fx is q inverse r. Accordingly, option D. This is end of the question. The question is value of integral 4 to 5.2 log x dx using Simpson's one-third rule with interval size 0.3 is 4 options A, B, C, D given. This question is from engineering mathematics from the topic numerical method, subtopic numerical integration. The method mentioned Simpson's one-third rule. Step size h value 0. That is h is size of the each of subinterval. After dividing the given interval, closed interval a comma b into n equal parts, each part having same length, that is divided by h, is called the length of each subinterval. So now the data, usually subinterval length denoted by h, 0.3. Lower limit not required to write because h is already known. If lower limit h value not given, then the formula for h is p minus a by n, where p is upper limit, a is lower limit. And the integrand is denoted by f of x. That is natural logarithm, that is basic logarithm x. Now y naught. Calculate the function values. F y naught is nothing but function value at a, that is a is 4 log 4. So please apply the calculator. 1.386 by 1. Function value at a plus h. A plus h now 4 plus 0.3, 4.3. So that is log of 4.3. Function value is log x, which is nothing but 1.458. Approximately I am writing. Y2 is nothing but function value at a plus 2h, which is nothing but a plus 2h is 4.6. That is log of 4.6. So this is equal to 1 point approximately 526. Y3 is equal to function value f of value at a plus 3h. A plus 3h value 4.6 plus 0.3 is 4.9. So this is log of 4.9. So approximately 1.589 and y4, because here n is getting 4, f of a plus 4h, a plus 4h value is 5.2, which is the upper limit. So when to stop for calculating these y values, ordinate values, function values, whenever function value reaching at upper limit b, then stop for calculating y1, y2, y3, etc. So this is log of 5.2, which is approximately 1.648. Thereby, Simpson's one-third rule, integral 4 to 5.2 log x dx is equal to h by 3 formula y naught plus yn. Yn means the last ordinate value. Usually this y4 in our concept. yn plus 4 times sum of the odd suffix y values, that is y1 plus y3, 2 into sum of the even suffix y values except the ends, end y values, that is extreme y values means y0 yn. So there is only y2, 0.3 by 3 into y0 plus yn, 1.386 plus y4 is 1.648 plus 4 times y1 1.458, y3 1.589 plus 2 times y2 1.526. So please simplify. This is equal to 1.8274. Approximately all options are up to 2 decimal places. You will be getting 1.8. So the answer is 1.83. Accordingly, the option is C. This is end of the question. The question is, consider the following differential equation. 1 plus y into dy by dx is equal to y. The solution of the equation that satisfies the condition y of 1 is equal to 1 is 4 options A, B, C, D given. This question is from engineering mathematics, from the topic differential equation, subtopic first order equation. The solution is so usually first order, first degree, this is differential equation, dy by dx is equal to f of x comma y. Most of the problems, not all the problems, can be solved by either variable separable method or linear equation method or Bernoulli's equation method or exact equation method, etc. So this is can be easily separated the variables, that is dE, which is the short form of differential equation, can be written as dy, the left side y variables and the right side x variables, that is 1 plus y by y into dy is equal to dx, which is variables separable form. So after that, integrating both sides, we get 1 upon y plus 1, both terms integrating with respect to y, integral dx, and then adding arbitrary constant or constant of integration. By y with respect to y, integration is log y, natural logarithm, basic logarithm. One integration with respect to y is y. Integral dx is x plus, let us say, equation 1. Use the given initial condition, that is y of 1 is equal to 1, whatever it may be condition, boundary condition or initial condition, using y of 1 is equal to 1, that is y value 1 when x is equal to 1, comma, equation 1 gives log 1 value 0 plus y value 1, x value 1 plus c. So this gives or simplifies c value 0. Back to equation 1, substitute. Therefore, log of y plus y is equal to x. Shift y to the right side, which can be written as log of y is equal to x minus y. Eliminating logarithm. So this is y is equal to e to the power x minus y. So e to the power x minus y is not in the option. E power x minus y can be written as e power x into e power minus y. So this is y into e power y. That right side e power minus 1 shifting to left side becomes e power y is equal to e power x. Any option? So this is the required solution. Accordingly, the option is D. This is end of the question. The question is, find the positive real root of x cube minus x minus 3 is equal to 0 using Newton-Raphson method. If the starting guess x naught is 2, comma, the numerical value of the root after 2 iterations in bracket x2 is round off to 2 decimal places. This question is from engineering mathematics from the topic numerical methods, subtopic numerical solution to algebraic or transcendental equation. The solution is usually the equation once the right side 0, all the left side terms denoting by a function fx, h of x, g of x as you wish, cubic function, cubical equation. So x naught value given to, they're asking x2. Method also mentioned Newton-Raphson method, NR method, positive real root. Okay. So for this, applying Newton-Raphson method, the step 1 is find the first derivative, that is dx square minus 1. And the x naught value already given to. So by Newton-Raphson method, comma, the iteration formula xi plus 1 is equal to xi minus f of xi divided by f dash xi. I is equal to 0 gives x1 is equal to x naught minus f of x naught divided by f dash x naught. X naught value to f of x naught, put x is equal to in fx, 2 cube 8 minus 2, 6 minus 3, that is f of 2. F dash x, that is f dash x naught, put x is equal to 2 in f dash x, 3 to 2 square, 12 minus 1, 11. So, this simplifies to 1.73 this shape. Next, I is equal to 1 gives x2 is equal to x1 minus f of x1 divided by f dash x1. So x1 value 1.73 and f of x1 in fx put x is equal to 1.73, that is 1.73 whole cube minus 1.73 minus 3, that simplifies to 0.48 divided by f dash x1. In f dash x, put x is equal to x1, that is put x is equal to 1.73 in f dash x. 3 into 1.73 whole square minus 1 simplifies to 7.98. So this simplifies to approximately, this is a symbol, up to 2 decimal places, 1.67. Please check. So the answer after 2 iteration, that is x2 value up to 2 decimal places is 1.67. This is the end of the question. The question is the mean and variance respectively of a binomial distribution for n independent trials with the probability of success as P are 4 options A, B, C, D given. This question is from engineering mathematics from the topic probability and statistics. Subtopic is distribution. So here expected value of the random variable, binomial random variable, variance. Mention the distribution, n independent trials, n is number of independent trials. So P is probability of success. Automatic Q is considered as probability of failure. So Q is equal to 1 minus P. When P is considered as probability of success, then Q is probability of failure. So there are standard formula. So implies mean of binomial distribution, short form BD, is n into P. N is the number of independent trials. P is the probability of success for any single trial. That is probability of an event that happen in any single trial, usually called probability of success. Next, they are asking variance. Variance of BD is NPQ. Usually this is denoted by symbolic notation expected value of x, and this is variance of x. PR of x. So the answer is NP, comma NPQ. That is here I can write NP. Q is nothing but 1 minus P. So variance is NP into 1 minus P. Mean is NP. So the answer is respectively NP, comma NP into 1 minus P. Accordingly, the option is P. This is another question. The question is value of 1 plus I whole to the power 8, where I is equal to square root minus 1 is equal to 4 options A, B, C, D. This question is from engineering mathematics from the topic complex variables, subtopic complex numbers basics. The solution is I square value minus 1. We know that. We have to find 1 plus I whole square. Looks like A plus B whole square, A square plus B square plus 2AB. I square value minus 1. So 1 minus 1 got cancelled, simplifies to 2I. Therefore, 1 plus I whole to the power 8 can be written as 1 plus I whole square and then whole to the power 4. 8 to the power m whole to the power n is a to the power mn. So this is 2I whole to the power 4. This can be written as a into b whole power m can be written as a power m into b power m. All from childhood class formulas. 2 power 4 I power. I square value minus 1 means I power 4 I square into I square, that is plus 1. So finally this is 16. So the answer is 16 according to option is C. This is end of the question. The question is if the Laplace transform of a function f of t is given by s plus 3 divided by s plus 1 into s plus 2, then f of 0 is 4 options A, B, C, D given. This question is from engineering mathematics from the topic Laplace transform. The solution is either by using initial final value theorem or by using the help of Laplace transform, then put is equal to 0. When you are applying, this is f of 0 means from initial value theorem, the function of s, this is denoted by f of s, capital F of s. That is, which is the Laplace transform of some function f of t. So, to apply initial value theorem, the f of s should be a proper function. Numerator degree less than denominator. So, by initial value theorem, comma, f of 0 is equal to limit s tends to infinity s times capital Fs. This f of 0 can be given in limit form. Limit t tends to 0 f of t. So this is equal to limit s tends to infinity s in s plus 3 upon s plus 1 into s plus 2. So usually limit s tends to infinity problems convert into reciprocal terms. So that is inverse terms. So in s plus 3 take outside s. So this can be written as 1 plus 3 by s. In s plus 1, s plus 2 also take s outside. So s into 1 plus 1 by s. S into 1 plus 2 by s. Limit s tends to infinity. So s square cancel. The remaining limit s tends to infinity. 1 plus d by s divided by 1 plus 1 by s into 1 plus 2 by s. Whenever s tends to infinity, 1 upon s tends to 0. So limit of a constant is itself 1 plus 0 divided by 1 plus 0 into 1 plus 0. So this simplifies to 1. So second method. Let capital F of s, that is this is s plus 3 divided by s plus 1 into s plus 2. Using partial fractions, this is a by s plus 1 plus b by S plus using partial fraction. That is A value 2, B value minus. Later you check. So implies f of t is nothing but L inverse of that fs. That is 2 by s plus 1 minus 1 by s plus 2. I have written 2 times s plus 1. The second fraction is s plus 2 having denominator is 2. So 1 by s minus a inverse is e power at. So 2 times e power minus t minus e power minus 2t. Since L inverse 1 by s minus a is a constant is equal to e power at. So therefore f of 0, put t is equal to 0, e power 0 value 1, 2 into 1 minus 1. So in both methods we got the same answer. One is the answer. Accordingly, option D. This is the end of the question. The question is, consider an n cross n matrix A and a non-zero n cross 1 vector P. Their product AP is equal to alpha square P. Where alpha belongs to a real numbers and alpha not equal to set minus 1 comma 0 comma 1. Based on the given information, the eigenvalue of A square is 4 options ABCD given. This question is from engineering mathematics, from the topic linear algebra, subtopic eigenvalues, eigenvectors. Solution. So square matrix given, non-zero vector P n cross 1 column vector, n rows 1 column. So eigenvector, this is the relationship between matrix and eigenvalue alpha square corresponding eigenvector P. Then they are asking eigenvalue of A square. So given A times P is equal to alpha square times P, where alpha square is eigenvalue of matrix A corresponding eigenvector P. So let us denote this is equation 1. We are asking eigenvalue of A square. So to get A square, pre-multiplying both sides by both sides by the matrix A. We get A into B equal to A times alpha square P. So here alpha square I can put in preposition because it is a constant according to matrix multiplication associative. So this is A square into P. Alpha square take out A into P. So just observe from equation 1, I can use AP is equal to alpha square P. This is alpha square times P. Since from equation 1. So therefore what we are having, A square into P is equal to alpha power 4 into P. Let us say equation 2. Now observe 1 and 2 that I am highlighting by matrix A changes to A square. Eigenvalue alpha square changes to alpha power 4. But eigenvector never changes. Okay. So eigenvector never changes. Matrix changes accordingly. Eigenvalue changes. Therefore, from 1 and 2, comma, alpha power 4 is the eigenvalue of matrix MAT matrix A square. So the answer is alpha power 4, that is alpha raised to power 4. Accordingly, option C is the end of the question.